and welcome to another episode of Science with Dixon. Today we're going to be looking at reaction kinetics, which, for anyone who doesn't know, is essentially just all the different things that affect the rate of a chemical reaction. First up, we're going to talk to some of you guys, the viewers, and see what questions you have about this topic. Let's get into it. Mohammed asks us, what actually is a chemical reaction? That's a good question, Mohammed, and here's your answer. A chemical reaction is the transformation of one chemical substance into another chemical substance. This is done by breaking and making chemical bonds between the atoms in that substance. Well, next up, Ishmael asks us this question. Well, Ishmael, collision theory is a theory that can help explain what is needed for a chemical reaction to occur. It says that for a chemical reaction to occur, the reacting molecules must collide with each other. It also says, even if they do, they may not react, as the molecules must collide with enough energy and with the correct orientation in order to react. This next one is from Stefan. Well, too bad about the test, but I can give you some examples of fast reactions for next time. Some examples are striking a match or the burning of petrol in your car. These are reactions that take less than a second to occur and happen all around. Next, Mr. Heaney asks us two questions in one. First, why would we want to speed up or slow down a reaction? Well, we might want to slow down a chemical reaction in order to study it, as if the reaction took less than a second, it would be hard to observe what happened. On the other hand, you might speed up a reaction that takes days or even longer in order to observe it as well. Additionally, in real life, companies may want to speed up the time of a reaction in order to create their product quicker. Mr. Heaney also asked, how could we slow down or speed up a reaction if we wanted to? Well, Mr. Heaney, lucky for you, that's what this entire episode is about. After this, I'll show you guys not one, not two, but 6 experiments and explain about the rate of reaction in this experiment. In this first experiment, we tested two things. Firstly, we tested if collision theory works, and secondly, how the surface area affects the rate of a reaction. As you can see in this video, we mixed the lead nitrate crystals with potassium iodide crystals. Only the crystals that were touching reacted, creating yellow lead iodide. This is because of collision theory, which states that reacting molecules must collide with each other in order for the reaction to occur. We then shake the contents of this test tube to make more of those particles collide, and as you can see, the reaction was much more complete. Additionally, we proved that surface area affects rate of reaction by doing the same experiment as before, but dissolving the chemicals beforehand. By doing this, we increase the surface area, therefore increasing the reaction rate. The reason behind this is because within an increased surface area, there are more particles able to collide at the same time, which makes the reaction go faster. This next experiment also tests how surface area affects the rate of a reaction. We had calcium carbonate in two forms, chips and powder, with the one in powder form having an increased surface area. As both calcium carbonates were dropped into the hydrochloric acid, with a balloon over the top to show the gas, we can see that powdered calcium carbonate created a much faster, more vigorous reaction, whereas the chips were a much less vigorous reaction. Looking at the results here, we can see that calcium carbonate only took 1 minute and 25 seconds to complete the reaction, compared to the chips, which took 24 minutes to stop reacting. Again, because the powder has a larger surface area to react than the chips, the reaction was faster. This experiment shows how heat can change the rate of a chemical reaction. We heated 4 test tubes, 4 of sodium thiosulfate and 4 of hydrochloric acid, and combined them at intervals of 15 degrees Celsius. We then measured how long it took for the reaction to have produced enough sulfur that the solution was opaque and you could no longer see the bottom. What these results show is that the higher the temperature of the solution was, the less time it took for the solution to turn opaque. This proves to us that heat increases reaction rate of a chemical reaction as shown by this graph here. The reason for this is because heat energy brings the reactions closer to achieving the activation energy, which is the amount of energy required for the reaction to work. as shown in this diagram. In this fourth experiment, we tested how concentration affects the rate of a reaction. We placed magnesium into 0.5 molar, 1 molar, and 2 molar hydrochloric acid and recorded how long it took for the ensuing reaction to occur. We plotted our results in a graph, and this was the result. As you can see, the higher the concentration, the less time the reaction took, decreasing at a rate of 13 seconds per 0.5 molar. What is the reason behind this? Well, the reason behind this is because the higher the concentration of the hydrochloric acid, the more molecules there are to be reacted with the magnesium. This means that the amount of collisions of these molecules which are going to be successful is more because there are more molecules overall. In this experiment, we test how using a catalyst, which is a substance that can be used to increase the rate of a reaction without being consumed, increases the rate of this reaction. In the experiment, we used copper 2 sulfate as a catalyst to increase the reaction rate of zinc and hydrochloric acid. In the reaction, copper 2 sulfate reduced the amount of energy needed to reach the activation energy, like shown in this graph. This meant that the reaction rate decreased from 5 minutes and 50 seconds to 3 minutes and 15 seconds with the catalyst. In this final experiment, we tested how light affects the rate of a reaction. In this metathesis reaction, we combined silver nitrate and potassium bromide to make potassium nitrate and silver bromide. Then, the silver bromide was filtered out of the potassium nitrate solution, which we then placed, with some in the light and some covered by a piece of paper. Then, in the silver bromide in the light, a decomposition reaction occurred, separating into solid silver and gaseous bromide. This reaction was catalyzed by the light because of the energy the light provided. So guys, let's go over what we learned in this jam-packed episode. First, we learned the basics of a chemical reaction. Then we looked at 6 different ways we can increase the rate of a chemical reaction. We learned that surface area, heat, concentration, catalysts, and light can all affect the rate of a chemical reaction. Hopefully you guys learned something and enjoyed it, and until next time.
Don't forget to hit the like button. Yeah. And subscribe to It's Up Here. And here's another video.